This unit we're going to be talking about rational functions. The unit itself is going to consist of 3 lessons. Lesson 1 being the different parts and how to graph a rational function. Lesson 2 we will cover operations, and then lesson 3 we will look at solving rational functions. So again, what essentially is a rational function? A rational function is a division of 2 polynomials. So basically a function that is a fraction at the end of the day. So 1 over x squared plus 2 divided by x minus 1, x minus 3 divided by x squared plus 2x minus 5. Okay, most of these functions are going to look one or two ways. They're either going to look like this, or they will look like that, this, or this, depending on what all you have going on. So again, 4 really distinct looks, but if you want to go even further than that, you can say the 2 on the left are similar. You just have reflections that have occurred, and the 2 on the right are also similar, just reflections have occurred. The key distinct point about rational functions is that they are discontinuous, meaning that they have holes or breaks in them. In this video, we will specifically talk about 2 key features of rational functions: the x and y intercepts and our vertical asymptotes. X and y intercepts we should be somewhat familiar with. Remember, the x-intercept is the place where the graph touches or crosses the x-axis. To find the x-intercept, you want to set y equal to 0 and solve for x, and then the exact opposite for your y-intercept. Y-intercept, place where the graph crosses or touches the y-axis. Set x equal to 0, and you want to do PEMDAS. Okay, this is going to result in a value. So on page 2, I have 3 examples. I'm just going to cover one. So to find the x-intercept, remember, just set y equal to 0 and solve for x. So if I have y value, you can just add in y equals, and we'll type this. We'll go to Desmos. Hardest part about these is making sure that you first hit division and then you type the top piece of your function. Once you get done with your numerator, you go to your denominator. And again, if we zoom out, we want the x-intercept, so wherever y is equal to 0 at. So -5, -1, and if I come and zoom out, I only see it at 2 places. the next intercept, remember, is going to be the y-intercept. To do this one, you just plug in 0 everywhere we see an x. So 0 squared plus 4 times 0 minus 5, all divided by 0 squared plus 9 times 0 plus 20. I get negative 1/4. And maybe if I hit home to zoom back in, and so I actually made a mistake on this example because I kind of typed a little fast and I had something that was 0 versus 20. So I actually need to change my X-intercept value, and it's still going to be 1. However, it's not going to be negative 5. And my y-intercept is where it crosses the y-axis, which was negative 0.25. Now, I got negative 1/4. It says negative 0.25. So if I type in negative 1/4, it will tell me negative 0.25. Just in case you're not good with fractions, you can do this. The next key feature of these are going to be the vertical asymptotes. Now, a vertical asymptote, or let's talk about what an asymptote is in general. An asymptote is it's an imaginary line or think of it as an imaginary wall. And if you get to this wall, or it's like you can't really get to it, but you approach it and you turn. So vertical, up and down. So what you'll see out of your graph is it do something like this. So your graph will be going, and then it'll get there, and then it'll run along the edge. In the same respect, it could be coming from this way and go along the edge. It could be coming like this and go along the edge. What makes this happen is your denominator of the rational function is equal to 0. Remember, if you divide by 0, we get an undefined, okay? So an extremely, extremely, extremely large value, not infinity, but you could almost think of it as being bigger than infinity. So to find vertical asymptotes, I'm going to erase this. You want to factor your bottom piece. So vertical asymptotes, factor our denominators. Now, if you're not good at factoring, what you'll do is you'll come to Desmos and you'll just type your bottom piece of the function in. So x squared plus 9x plus 20. And we're going to get a quadratic. And we want to find where it crosses the x-axis. So our solution, x equals -4 and -5. So the factors is just the opposite sign. And then x plus 5. You can verify this by typing our factors in. When you do, if you notice, the green and purple graph overlap, so they're the same. So our vertical asymptote is going to occur at x equals -4 and x equals -5 on our irrational functions. So hide your bottom. Let's look at our top. So we say x equals -4, x equals -5. I'm going to use two different colors here. So remember, a asymptote is truly an asymptote if the graph approaches it and then makes a hard turn either up or down, coming from either left or right, but it does not cross it. So if I look at x equals -4, as the graph is coming from left to right, it makes that bend and it gets really close, right? So the more I zoom in, the closer it gets, but it never actually really touches it. However, if I try x equals -5, you can see that they touch right around at this value right here, okay? If it touches, it's not a vertical asymptote. So my vertical asymptote is x equals -4. What I want you to do is try these next two examples, listing the x-intercepts, the y-intercepts, and the vertical asymptotes.